I am inventing a library of building blocks so that my nieces and nephews can learn how things work by building toys like this crane. New designs can be manufactured almost anywhere by a 3D printer for pennies. This video will introduce two new sets of blocks that will turn this pile of planks into a stable tower for the crane to do its lifting thing from. Unlike specialized toys, these building blocks are designed to be adaptable and keep pace with imagination. While meant for fun, this project aims to increase accessibility to resources that are intuitive and allow for the complex to be experienced instead of interpreted from images that are on a screen or a textbook's page. Turning these planks into a crane's tower will be done using the 3-4-5 ratio. Before that, I must explain that these MDF planks are of varying lengths, allowing for a grid of 1-inch holes to be constructed in 3 dimensions. These holes are attachment points for hardware, and the planks are a skeletal structure which when combined will allow for an incredible number of future projects to be constructed. Planks are restricted to lengths that correspond to a natural number from 1 inch up to 16 inches. In order to build a crane tower, a way to brace planks so that they stay aligned with the skeletal grid is needed. This is where the 3-4-5 ratio comes in. I will use inches, but the following is true no matter the unit. If a 3-inch, 4-inch, and 5-inch lengths are arranged to all intersect each other, the result is a triangle with a 90-degree angle where the 3 and the 4-inch lengths meet. This means that a plank held in this orientation to the 3-inch and the 4-inch planks can act as a brace, allowing planks that align with either the 3 or the 4 side to match the toy's skeletal grid. Depending on the hole's alignment for each plank, these new building blocks will hold things together by tying the 5 brace into the grid. Blue blocks intersect the 5 and the 4 sides, while red blocks connect the 5 and the 3 sides. If the planks being assembled have overlapping holes, no blocks are needed, as the center of each anchoring hole becomes the intersection point of the 3-4-5 ratio. It is important to point out that the planks used in this situation will measure 4, 5, and 6 inches, so that there is enough material to incorporate the bolts. One last point before assembly. Any 3 lengths that correspond to the 3-4-5 ratio may be used to make a triangle that has a right angle. Here are 3 triangles with sides 3, 4, 5 inches, 6, 8, 10 inches, and 9, 12, 15 inches. To build the crane's tower, lengths 9, 12, and 15 inches will be used for the bracing. The tower comes to a height of 30 inches. It is formed by 2 sides where blocks help the 15-inch braces connect into the skeletal grid. If these 2 sides are braced 8 inches apart, the measurement from this hole's center across to this hole's center is 9 inches. Moving up 12 inches locates the 3rd hole that is needed. Connecting the first hole's center and the 3rd hole's center with a 16-inch plank brings the first 2 sides of the tower into parallel, keeping them spaced 8 inches apart. And importantly, the horizontal and vertical planks are in line with the skeletal grid. With these 9, 12, and 15 triangles and a few beams in place, the tower is reasonably solid and ready for the crane to be attached. Though raised from the floor, the former resting spot remains troublesome. The tower has no ability to adapt to any variations, and though only a small wobble is present at the bottom, movement at the top is greatly exaggerated thanks to the newly found height of the crane. The solution is to use an inclined plane. Well, a more precise one is needed. Traditionally, an inclined plane is explained as a device used for moving a mass to different heights. The variable heights is what is of interest in this case. By moving along the red hypotenuse, large or small changes in the distance from the black bottom can be achieved. This is why the inclined plane worked. The problem is that it is bulky, can only support the tower on a hairline, and can't be bolted into the skeletal grid in any logical way. The answer is to wrap the inclined plane around a cylinder, resulting in a familiar screw pattern. Traveling along the red hypotenuse will still vary the distance above the black bottom line. These two blocks incorporate this much more compact solution. The yellow block can be anchored into the skeletal grid, leaving the orange one to adapt to variations in the floor. The blocks introduced in this video have solved the problem of how to construct a stable tower for the crane. My next video will be about how to turn the crane's top so that it pivots around this newly constructed tower. Thank you very much to you, the viewer, for watching this video. It is a project of love for my nieces and nephews. Before I go, I have a disclaimer to make. I have no education or experience in engineering or design, and do not suggest that these parts be produced at home or the project be attempted in any way. This due to any unforeseen failures or dangers. The parts are cataloged at printables.com on my page, The Odd Uncle. I make files available in hopes that people may investigate them, find improvements, and send suggestions my way. I try to, daily, for entertainment purposes, release a short video introducing a new building block. These can be found on platforms like TikTok, YouTube, and Instagram. Again, thank you so much for your support. Any critiques or suggestions would be greatly appreciated. And to my nieces and nephews, I love you so much. Take care, everyone.